Covalent bonds. Now, so far we have named ionic bonds and we have found the chemical formula. When we talk about covalent bonds, they're going to have different methods for finding the chemical formula and the name. So first we're going to talk about what a bond that is covalent actually is. It's a bond between two or more nonmetals. No metals are going to be in a covalent bond. These electrons, since they're both nonmetals and they're all negative, they all want electrons. So instead of being transferred, they don't have anybody that wants to get rid of it. They all want electrons. They're just going to share their electrons to fill their outer shell. Okay, so when we are naming covalent bonds, we are going to name the first nonmetal and add a prefix. So we are going to name first nonmetal and add a prefix. Now a prefix comes in front of the word. Since we're not crossing charges here because we aren't transferring electrons, we need to know how many of each atom we have. So we need to add a prefix. Now our prefixes over here are as follows, and you do need to memorize this. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca, like a decade. So we put those in front of the first nonmetal to show how many we have, and we'll know that from our formula, and we just don't put mono in the first spot. So we're going to add a little note here and put never mono in front of first nonmetal. All right, the second part that we do is we name the second nonmetal. We add our prefix and we end with "ide." So our example is SiO2. Okay, when we go to name this, it says we're going to name our first nonmetal, silicon. We're going to add a prefix. Well, there's no number behind it, so I only have 1. And mono is the prefix for 1. We don't put mono in the first spot. So I just write silicon. And then I have oxygen right here. Now, I start with a prefix. For 2, that's going to be di. I write my nonmetal and put IDE on the end. Silicon dioxide. All right, now let's look at something that we need to highlight a few things for. So if you have your highlighter, grab it. Okay, so binary covalent bonds include 2 nonmetals. All right, 2 nonmetals, and they share their electrons. So there's a few differences. The names of the covalent compounds must include prefixes to show the number of atoms for each element. The first atom is named after the element it presents. If there are 2 or more, we use a prefix. The prefix mono is never used for the first element. The suffix "ide" is then added to the end. So CO2 would be carbon dioxide. For P2S, it would be diphosphorus, 2 phosphorus, pentasulfide, 5 sulfurs. So let's look at some of these examples right here. All right, if I have carbon and oxygen, I need to name my not metal first, which is carbon. There's only 1, and I can't put mono in this first spot, so I'm going to put carbon. I've got 1 oxygen, which would be oxide, but we have to put a prefix, and it's going to be monoxide. All right, here, this was our example. We have one silicone. I don't put mono in the first spot, so I'm going to write silicone. Di for 2, oxide. All right. Now, I want you to name the rest of these, okay? I do want to name one right here where it's got a 2 in the first spot. There is a 2 here for hydrogen. The only reason we haven't put a prefix here is because there's only 1 in the first spot. There's 2 here. So I'm going to call this dihydrogen. Remember, no iod on the first element. There's only 1 oxygen, so monoxide. All right. What I need you to do is I need you to flip to page 10. Excuse me, page 11. Now, the good thing about page 11 is we have everything we need right here. We have an example of several compounds that are covalent and all of the prefixes. So, with a covalent compound, if you have the name carbon dioxide, we don't look at charges, remember, because we're not transferring electrons. So, all we do is look at the prefixes. So, carbon, I don't see a prefix, so I'm assuming there's just 1 dioxide. Di means 2, so I have 2 oxygens. Phosphorus, just 1 triiodide, so iodine with a 3. Sulfur, dichloride, that means there's 2 chlorines. Nitrogen, trifluoride, which means there's 3 fluorines. Dioxygen, so O2, difluoride, F2. Now we have to have the names. Now remember, a prefix goes in front of every element unless there's only 1 in the first spot. So right here I have 2 nitrogens. So I'm going to call that dinitrogen. I have 4 fluorines, so it's tetrafluoride. All right. Sulfur, just 1, so I'm not going to put mono in the first spot. I'm just going to write sulfur. Tetrachloride. All right, chlorine, I just see 1, that is Cl. Notice it's a lowercase l. So I just have chlorine. And then 3 fluorines, so trifluoride. Silicon and oxygen, I have 1 silicon, so I just write silicon. And I have 2 oxygens, so dioxide. Now this one's a little tricky. I've got 4 phosphoruses, so it's tetra, phosphorus, and then 10 oxygens, so decaoxide. Or you could say decoxide. All right. So we're determining these if they are ionic or covalent and giving them their names. I want you to cross this one out. This is called barium nitrate. And because it's not binary, I just want to cross that out. It's got more than 2 elements, so we're just going to cross that out right now. So this one has carbon and oxygen. Those are both nonmetals, so that is covalent. That means I use prefixes. So I'm going to name that carbon monoxide. PCl3, phosphorus and chlorine are both covalent. So phosphorus has just 1. We're going to write monophosphorus. So it's phosphorus trichloride. K and I. Potassium is a metal, so that's ionic. And now go back to our old ionic names. We just named metal, potassium. Non-metal and IDE, so we do iodine. The reason I did not use prefixes is because it is not covalent. Carbon and fluorine are both nonmetals, so it's covalent, and that would be named carbon tetrafluoride. MgO, that's a metal, so I've got ionic, and I just name it magnesium oxide. Cu2S. This is copper, so that is actually going to be a transition metal. So we're actually going to cross that out. It would be copper with a Roman numeral 2 in a parentheses and then sulfide. Sulfur and oxygen, covalent. So we're going to use prefixes. Not in the first though, because that would be mono. Sulfur dioxide. Nitrogen and chlorine, both covalent, 2 nonmetals. Nitrogen trichloride. Last one, we've got xenon, which is a noble gas, and fluorine. Those are covalent. So we've got xenon hexafluoride. All right, now let's flip to the next page, page 12. This is where we're going to end today. I want you to look at some of these. Now, I know that some of them are going to be examples of metalloids, and that is okay. But these say naming covalent compounds. So these metalloids are going to act as covalent nonmetals. So ammonia is NH3, just so you know that. And look how we do these. Just remember antimony tribromide. Let's find hexaboron. That means I have 6 borons. And it says silicide. Now, they didn't put a mono on there. They probably should have. Well, actually, let's just cross this out because that is not named correctly. Phosphorus triiodide. Phosphorus, P. Iodine, there's a tri there, so that's 3. Dinitrogen trioxide, 2 nitrogens, 3 oxygens. Iodine pentafluoride. So we got iodine and fluorine. We got 5 fluorines. Hydrogen iodide. Now hydrogen's odd because it does have a charge, right? It's the same as iodine, so we're just going to write Hi. All right, and chlorine dioxide. So we have ClO2. And you can do antimony tribromide on your own. Find antimony on your periodic table and then 3 bromines. All right, write the names for the following covalent compounds. Now, I see 4 phosphoruses. So it's tetra, phosphorus, penta for 5, sulfide. This one is dioxide, selenium, hexafluoride. And this is 2 silicones, so it's disilicone hexabromide, and that is all one word, hexabromide. This one's just 1 sulfur, so sulfur, tetrachloride. This one, carbon and hydrogen, is carbon, tetrahydride, diboron, monosilicide, and there you will find this one is a metalloid, 2 metalloids, so that does, a lot of times we'll call that boron silicide. We'll star this one and come back to that one. And then we've got nitrogen trifluoride.